Video we're going to talk about doing mixed naming, which means you're naming compounds or providing formulas for all different types of compounds or molecules. But really what I want you to do is follow this flow chart. And it all comes down to asking yourself a specific question based on where you are on this chart. So the first question you need to ask yourself when you're figuring out how to name or write the formula for a substance is, what does it start with? Does it start with a metal or ammonium, or does it start with a non-metal? If it starts with a non-metal, then that means that you have a molecular compound. And there's two types of molecular compounds that you're going to be responsible for. One are non-acids, which we use prefixes for. And then if we have an H in front, we know that it's an acid, and there's two possibilities there. It could either be binary, where it's just hydrogen and one other element, and we would use the phrase hydro, put the name of the element there, ic acid. If there is a polyatomic ion present, what we're going to do is recognize that 8 will become an ic acid and ite will become an us acid. Now going back, if the compound does start with a metal or ammonium, that means it's ionic. And if we're writing the names for these, we don't use prefixes, and if we're writing the formulas, we balance the charges. And there's a couple different possibilities you can have with ionic compounds. You can have binary ionic compounds, which are just two elements. You can have ternary ionic compounds, which contain polyatomic ions. So if you see more than two elements present in a formula, that means you have a polyatomic ion. Look at your list. And if you see that it ends in ate or ite, that means you have a polyatomic ion. And there are a couple exceptions to that, but like hydroxide, cyanide. And both of these situations can have transition metals. And if there are transition metals present, we need to use a Roman numeral to indicate the charge. So these are our rules, and now let's do a couple practice applications. I put a couple problems up here in blue, and then we wrote out the formulas or names depending on what we were provided with. The first problem I put up there was phosphoric acid. So when you see phosphoric acid, we know it's an acid. We know it's not binary because it doesn't start with hydro. And since we say it's an ic acid, that means it had to have the 8 anion. So phosphate would be combining with H to make the acid. Since phosphate has a -3 charge, and we consider hydrogen to have a +1 charge, which is what that says here. It doesn't say histol, it says H is +1. So we would need 3 hydrogens to balance out the phosphate. In the second example, we have HF. So we look over here, we know it starts with an H, so it's an acid. Since it's only 2 elements, it's a binary acid, and we'd say hydroblankic acid, so in this case it would be hydrofluoric acid. In the next example, we have C2H6. So we know it doesn't start with a metal, so we know it's a molecular compound, and since it doesn't start with an H, it's a non-acid. We just use prefixes. The prefix for carbon would be 2, it would be di, because there's 2 of them, and for the hydrogen, you would have the prefix hexa to represent the 6 hydrogens there, changing the ending to IDE. In the next example, aluminum sulfate, aluminum's a metal, so it's an ionic compound, and since it ends in ATE, that means we have a polyatomic ion present. So we look on our list, we see that sulfate's SO4 with a -2 charge. Knowing that for ionic compounds we have to balance the charges, so +3, -2, the ratio that these two are going to combine in to form a formula unit is Al2 sulfate 3. The next example, I give you the formula Fe2 carbonate, take it twice. Since you have more than 2 elements there, and you know iron's a metal, so it's ionic. It's ternary because you have a polyatomic ion carbonate there. Again, you can tell if there's more than 2 elements present, you have a polyatomic ion carbonate. Now, iron is a transition metal, so we have to add a Roman numeral in there. In order to determine the charge of the metal, what we have to do is look at the ratio that the ions combine in. We know carbonate has a -2 charge and that we have 3 of them. That means that the carbonate contributes a total of -6 for a charge. So that means the iron needs to balance that out. So it has to equal +6. Since we have 2 of them, each one would have to be +3, and therefore we'd write the Roman numeral 3 to represent the charge of the iron. The last example I put up here, magnesium, which is a metal, tells you it's going to be an ionic compound. Since you see nitride, IDE will indicate to you that it's just the element as an anion, so nitrogen represented as an ion. So again, balancing charges for ionic compounds, Mg +2, N -3. That would be the ratio that they would come together in. So again, when you're writing formulas or names and you're given a mixed bag of compounds to write with, please follow this flow chart and ask yourself the guiding questions. Is there a metal present? And then go from there as to what the possibilities would be.